Hello, everyone. Welcome back to our video series where we are reviewing the LEED Green Associate Exam Preparation Guide textbook. So this video is about chapter 8, and that is energy and atmosphere. It's a large and very important sector. So let us take a look at the credits and prerequisites in this category before we dive deeper into the chapter. So in the energy and atmosphere credit category, there are 33 possible credits, and there are 4 prerequisites, 33 possible points for the credits, and there are 4 prerequisites and 7 credits. So prerequisites are as follows: fundamental commissioning and verification, minimum energy performance, building level energy metering, and fundamental refrigerant management. And those are prerequisites, so they are required. Then the credits: enhanced commissioning, optimized energy performance, advanced energy metering, demand response, renewable energy production, enhanced refrigeration management, and green power and carbon offsets. So the chapter's objectives are to explain the environmental concerns related to energy use and the importance of reducing it. Then we'll be able to list the main goals of the energy and atmosphere category, identify the standard used for the baseline case in the energy and atmosphere category, explain the strategies to reduce energy demand, explain how to reduce the impacts of building loads, explain the strategies to increase energy efficiency, compare the differences between on-site renewable energy and off-site renewable energy, describe renewable energy certificates and how they're used as a carbon offset, explain the trade-off dilemma of refrigerants, and explain the importance of measuring and verifying ongoing energy performance after the owner takes possession of the building. So let's begin with the energy atmosphere credits. And the credit category of the LEED rating systems have 5 clear goals: reduce energy demand, increase energy efficiency, replace fossil fuel with renewable energy and carbon offsets, eliminate the use of harmful refrigerants, and monitor ongoing performance. So as far as the baseline and design cases, energy conservation is the main goal of the energy and atmosphere category. And we know that commercial buildings account for almost 20% of the US energy use. And building loads such as HVAC, lighting, and water heating systems account for a majority of that energy use. So there are baselines that are established by third-party standards organizations. So for example, the ASHRAE, or the American Society of Heating, Refrigeration, and Air Conditioning Engineers, and ANSI, the American National Standards Institute. So one of the most important standards here is ASHRAE 90.1-2010. So as far as the reducing energy demand intents, we can say that the intent of the reducing energy demand is to reduce the peak amount of energy used in the operation and maintenance of a building and the energy use of the occupants. So, and there are a few strategies to reduce energy demand. Reduce building footprint. That can reduce the demand for energy. And mixed use rooms in buildings or shared use rooms between buildings mean less space is utilized to fulfill the same building program. Then the next one is incorporate passive design. That is critically important to determine early in the design process whether energy savings can be achieved from passive design strategies such as the use of solar energy, daylight, and natural ventilation. And please refer to the textbook. There are a lot of images and graphics that will definitely help you with navigating through this credit category. Then also what can be created is the high performance building envelope can be created, and that's the exterior surface of the building that includes walls, windows, roof, insulation, and flooring. Also, we need to establish design and energy goals for commissioning. And the design and energy goals is the first step to reduce an energy demand. And although commissioning may seem like an unnecessary step, it's actually very important. And that is, again, the prerequisite, so fundamental commissioning and verification. And no other LEED credits can be earned without achieving the prerequisite. So although like maybe upfront cost is expensive, the data shows that actually the financial benefits come over the use of the building. So throughout the years, that will definitely be return on investment. Also, what can be done is we can install sub-meters and automated building controls. And monitoring energy using is the foundation for reducing energy demand. So what else is important here in this aspect is that if the project installs new or use existing building level energy meters or sub-meters, that can be aggregated to provide building level data representing total building energy consumption. And that is the credit advanced energy metering. So that requires that projects install advanced energy metering for all whole building energy sources used by the building and individual end users representing 10% or more of the total annual consumption of the building. The next one is increasing energy efficiency. And that is to accomplish the same amount of work with less energy expended. So the intent of the increased energy efficiency is to design and implement building systems that do not use more energy than needed to maintain the comfort of the occupants or to accomplish the tasks the building was designed for. There are a few strategies here. So participating in the demand response program, and the DR program or demand response program is a program offered by participating utilities nationwide to encourage large energy users to reduce energy loads during peak energy usage times in exchange for reduced rates. It doesn't necessarily work for every company and every organization, but that is a good strategy. Benchmarking buildings is a means to compare one data set to an optimal data set for purposes of improvement. Also, the next thing is to utilize high performance building systems. And there are always systems that are more efficient. And they may cost twice as much as the older ones, but they save a building owner a lot of money through reduced energy bills. They emit reduced levels of toxic emissions and can last twice as long or more as their inefficient counterparts. So please return to the book and check. There is a beautiful chart showing the life cycle cost analysis. And that's for the HVAC system, for the electric usage, natural gas usage, and other things. So please back this video up with the textbook. Another one is specify high efficiency appliances. And Energy Star certified appliances such as refrigerators, clothes washers, they incorporate advanced technologies and use 10 to 50% less energy than the standard appliances. So always remember to specify the energy efficient appliances. Then implement energy modeling. So that is the strategy that is used during the schematic design. So the building is analyzed in the computer, and That can be done in Sapphire, for example, if the SketchUp model is plugged in there, and that can be done early in the process, so we potentially know the savings. Producing renewable energy. So that can be produced either on-site or off-site. And the intent of producing renewable energy is to offset fossil fuel usage, thereby lessening the amount of CO2 and other house gases and pollutants released into the environment. There are a few strategies that are available here. So we can install on-site renewable energy systems, and that will suffice for the credit renewable energy production, and that will give us 1 to 3 points for that installation. And those can be solar power, wind power, bioenergy, geothermal energy, or hydropower. We can also purchase off-site renewable energy. So, for example, if on-site wind turbines cannot be built, project teams can arrange to purchase green power from off-site wind power generators. And the renewable energy certificates, or RECs, that is the certificates that can be purchased for that off-site renewable energy, and that can also reduce the demand for energy. Green E certification program is a third-party rating system for renewable energy run by the Center for Resource Solutions. So that is actually a good program, and I highly recommend to actually investigate it a little more and see what can be done for your project. Carbon offsets. Beside RECs, LEED V4 recognizes any carbon offset from a greenhouse gas emissions reduction project within the United States that is Green E certified. The next one is refrigerant management, and that is needed to reduce the environment impact. So the intent is actually to reduce that harmful harmful refrigerants, because the indirect effect is the production of CO2 when electricity is generated to power generation equipment, and also the refrigerants leak into the atmosphere. So the strategies that are here to help you with the refrigerant management are as follows. Refrigerant trade-off. The ozone depletion potential, or ODP, is much smaller than the ODP of the CFC-based refrigerants. Refrigerant elimination. The single most ratified treaty in the history of the United Nations, the Montreal Protocol, is an international treaty eliminating and phasing out the use of harmful refrigerants that deplete the ozone layer. It was signed by 197 countries. The Montreal Protocol bans CFCs and phases out HCFCs by 2030. So that's like a global commitment. Ongoing energy performance. So a LEED certified new construction building is only as green as the owners and occupants keep it. So the effectiveness of energy efficiency and carbon reduction measures cannot be monitored without measuring the ongoing energy performance through commissioning, retro-commissioning, submetering, building, automation, and benchmarking. And please refer to the chart here, and that shows the HVAC refrigerants. So it shows the CFC, or chlorofluorocarbons, then HCFC, or hydrochlorofluorocarbons, then HFC, hydrofluorocarbons, and natural refrigerants such as carbon dioxide, ammonia, and propane. So when you prepare and honor project requirements from the basis from which all design, construction, acceptance, and operation decisions are made, by incorporating the green energy goals of the project into the OPR and continually benchmarking the building against them, the building will continue to achieve savings and reduce its environmental impact throughout the lifetime. And also some incentives can be provided for building occupants, whether they're tenants or employees. Building occupants have a significant effect on the use and performance of the building. So when building occupants are regularly given benchmarking style reports on energy efficiency, it allows them to become involved in energy use reduction and efficiency goals. Also, preventive maintenance is an important part, and that works for buildings also. So yearly tune-ups on all systems will catch inefficiencies, leaks, cracks, etc., and should be written into the OPR or the owner's project requirements. So there are a few key terms and definitions here. Let's go over them real quick. So the first one that I would like to mention is the ASHRAE 90.1-2010. And that is a standard that sets the minimum requirements for energy efficient design of most buildings, except low-rise residential buildings, by offering in detail the minimum energy efficient requirements for design and construction of new buildings and their systems, new portions of buildings and their systems, and new systems and equipment in existing buildings, as well as criteria for determining compliance with those requirements. Another one is BTU, or British Thermal Unit, and that is the amount of heat required to raise the temperature of 1 pound of liquid water 1 degree Fahrenheit, such as from 60 Fahrenheit to 61 Fahrenheit, for example. This standard measures of energy is used to describe the energy content of fuels and compare energy use. Building envelope, the interface between the interior of a building and the outdoor environment. Reducing the transfer of hot and cold air through the building envelope is important for energy efficiency measures. Insulation, air sealing, and windows can play an important role in minimizing heat transfer. Building footprint, that is the area of ground that the building occupies as defined by its perimeter. Building loads, the amount of energy and the devices and systems that use the energy in a building. Carbon footprint, the amount of greenhouse gases and specifically carbon dioxide emitted by something such as a company or the manufacturer and transport of a product during a given period. Carbon offsets, a purchasable form of trade that funds projects that reduce greenhouse gas emissions, such as forest restoration, power plant and factory updates, or increases to the energy efficiency of buildings and transportation. Chiller, a machine that removes heat from a liquid by a vapor compression or absorption refrigeration cycle. This liquid can be circulated through a heat exchanger to cool air or equipment as required. CFC, or chlorofluorocarbon, any of several simple gaseous compounds that contain carbon, chlorine, fluorine, and sometimes hydrogen are used as refrigerants, cleaning solvents, and aerosol propellants, and in the manufacture of plastic foams that are believed to be a major cause of stratospheric ozone depletion. CFCs are banned in many countries, including the US. Commissioning is the verification after construction that the structure and its systems and subsystems meet project requirements as intended and designed. Commissioning authority, that is a third party contracted by a building owner who reports directly to the owner and oversees the incorporation of the design and energy goals throughout the lifetime of a project. Demand Response Program, or DR program, a program offered by utilities that allow large energy users to reduce energy loads during peak energy usage times in exchange for reduced rates. Energy efficiency, utilizing less energy to complete the same amount of work. Energy Star Portfolio Manager, that is an EPA-provided building benchmarking system that is the most widely used in the US. The energy and water data for a building is entered into a web-based tool that then displays where the building type falls in whole building energy use compared to other buildings of the same type. Greenhouse gas emissions are also measured. Energy use intensity, or EUI, a metric that expresses a building's energy use as a function of its size. HCFC, or hydrochlorofluorocarbon, a refrigerant used as a replacement for CFC refrigerants and propellants in aerosol canisters considered to be less destructive to the atmosphere. HFC, or hydrofluorocarbon, a refrigerant that is considered a long-term replacement for CFC and HCFC refrigerants since it consists of hydrogen, fluorine, and carbon, but not ozone-damaging chlorine. It does, however, contribute in small amounts to global warming. Lighting power density, or LPD, the installed lighting power per unit area. Mechanical ventilation, the process of supplying, directing, and removing air from an indoor space by mechanical means. And that's the opposite of the natural ventilation. Megawatt hour, a unit of energy equivalent to 1 megawatt of power expended for 1 hour of time. Montreal Protocol on Substances that Deplete the Ozone Layer, an international treaty that was adopted in 1987 to eliminate the production and consumption of ozone-depleting chemicals, ratified at the United Nations by 197 countries and the European Union. The Montreal Protocol bans the uses of CFCs and phases out the use of HCFCs. Net Zero Energy Project, a project that uses no more energy from the grid than it can produce on site. Passive design, a design strategy that uses natural climatic conditions to heat, cool, or light the building. Performance monitoring continuously tracks efficiency matrix of energy, water, and other systems to achieve increased levels of efficiency. Photovoltaic energy, or PV energy, electricity from photovoltaic cells that converts the energy in sunlight into electricity. Renewable Energy Certificate, or REC, a tradable commodity sold by producers of renewable energy in the open market, such as a stock exchange, which supports the production of additional renewable energy. One REC represents 1 megawatt hour of renewable energy produced. Retrocommissioning, a commissioning process that can be performed on existing buildings to identify and recognize system improvements that make the building more suitable for current use. And this wraps up our chapter 8. I will see you in chapter 9. Thank you.